Hello everyone. Now we have a new concept, which are going back to proofs. Now we have ways to prove if triangles are congruent or not. And the first way that we're going to explore is called the side-side-side proof, or side-side-side congruence. And what this means is that with three pairs of congruent sides, we have that the triangles themselves are congruent. So three pairs of congruent sides, there's one pair, here's our other pair, and our last pair, three pairs in total, would show that these two triangles are congruent. Now let's we also have side angle side. So what this says is that if we have a side and two pairs of sides that are the same, and an included angle that's the same, the two triangles are congruent themselves. So what that looks like is I have one pair of sides here, another pair of sides here, and what it means by the included angle is it has to be the angle that touches the two pairs of sides that we're using. So that angle would be in here, the one between the two sides. These two angles are the ones that have to be congruent. If it were any of the other two angles, it would completely mess up the proof. So let's remember we have a list of ways to prove sides are congruent. Now, it could just be given to us. We could use the midpoint theorem, which states that a midpoint creates two congruent sides because it splits it up evenly in half. And we have what's called the reflexive property, where a side can be congruent to itself. And that might make little sense now, but we'll see what it looks like when we actually cover the proofs. And then we have a larger list of reasons why angles are congruent. Angles can be congruent for, well, it's given if we have vertical angles. If we have parallel lines, that's always a key that we have congruent angles somewhere in there. Parallel lines are just one of the number one ways to identify congruent angles. And finally, we have the angle bisector, which is kind of like the midpoint. An angle bisector is a line that cuts an angle in half into two congruent parts. So, with all that said, and we have CP/CTC, of course, which is one of the greatest things we could use. If we already know this, we can establish the fact that angle A is congruent to angle D. Angle B is congruent to angle E. And angle F is congruent to angle C. And it also determines the sides. So AB is congruent with DE. BC is congruent with EF. And that AC is congruent with DF. So if we have this established, it shows us all this information here, which becomes a very useful thing to know later on. So, side-side-side congruence. Here's the steps on what we have to do. We have to show that we have three pairs of congruent sides. So if we establish that AB is congruent with ED, for instance, that's one pair of sides. We have established that BC is congruent with EF. And lastly, if we establish that AC is congruent to this third side, DF, Then we can prove that triangle ABC is congruent with triangle DEF. So we must establish these three facts first, and then we can conclude that the two triangles are congruent. So let's see what this looks like. We have two triangles as seen in the diagram. Our given is that PQ is congruent to ST. So on our first statement, that we could put that as a reason. Usually the first reason is always given. Another given is that QR is congruent to TR. So QR is congruent to TR, that's also given. And that R is the midpoint of PS. That's our third given. So already most of the proof is filled out for us. Now I have to establish that PR is congruent with SR. Well, if we look, PR here is congruent with SR here. Well, that follows directly from the fact that R is the midpoint. If R is the midpoint, it's splitting PS in half, thus creating two congruent parts. Therefore, my fourth reason is going to be the definition of midpoint. The definition of midpoint states that if we have a midpoint on the line PS, it cuts it into two congruent pieces, PR and SR. And then finally, if we look at what we have that QR, so QR is the same thing as TR, and that PQ is congruent with ST. We have three pairs of congruent sides, 1, 2, 3. Therefore, triangle PQR is congruent to triangle STR by side, side, side congruence. And as we can see, these proofs are not the most complicated things in the world. We just have to maintain a good logic when we're writing out our explanations.